Okay, good day everyone. So for this recorded discussion, I will going to discuss na the problem solving or the solution that are included in waves. So dun muna tayo sa topic natin na waves. So first, we have here the topics of period and frequency. So for our first problem, calculate the frequency and its period if a pendulum completes 30 cycles in 15 seconds. So from the recorded discussions about concepts of waves, I already discussed there the formulas for frequency and period, also the difference between the two. So let's write all the given first. So for our first given, we have 30 cycles, then we have the time na 15 seconds. So dito sa cycles, wala tayong ginagamit na ibang quantity but the cycles lang mismo. So for us to get first the frequency, we have the formula cycles divided by time. So substitute lang natin. Cycles natin is 30 cycles divided by the given time, 15 seconds. So our answer is 30 divided by 15 is 2. And sabi nga natin, cycles per second is equals to hertz. Our unit for frequency is hertz. It means that one cycle per unit time. Cycle per second is equals to hertz. So we have 2 hertz as the frequency. Now, for period, again, our symbol for period is the capital letter T. And kahit dun sa rotational motion, I mentioned to you that we can get the period by 1 divided by frequency. So we have 1 divided by yung nakuha nating frequency, 2 hertz. So 1 divided by 2 is 0.5 and our unit for period naman ay seconds. Okay, so ito yung ating final answer sa first question. This is the frequency of pendulum and this is the period of pendulum. Okay, so next sample problem. So this is our second and third example. So number 2 muna. Calculate the period of pendulum that has a frequency of 10 Hz. So for our given, we only have the frequency and it is equals to 10 Hz. Ang hinahanap natin is period. So for us to get the period, T is equals to 1 over F. So 1 divided by the frequency 10 Hz. So 1 divided by 10 is 0.10 seconds. So ganun lang kadali pag period ang hinahanap. So next one, calculate the frequency and the period of a child swing that completes 10 cycles in 25 seconds. So let us all write the given. We have 10 cycles and the time is 25 seconds. So we cannot get or we will not get the period if we do not have the value of frequency. So we need to solve first for the frequency before we get the period. So we have here frequency is equals to cycles over time. So we have 10 cycles divided by 25 seconds. So 10 divided by 25 is 0.8. Since we are talking about frequency, our unit is hertz. So next, we already have the value of frequency. So next one is the period. Period is equals to 1 divided by frequency. So 1 divided by our derived frequency, which is 0.8 hertz. So 1 divided by 0.08 hertz is 1.25. Hindi na hertz ang unit, but since we are talking about period, our unit is seconds. And also the unit was already discussed to you in the recorded discussion of the concepts. So ganyan lang ang pag-compute ng period and frequency. So next, we have the topic na Hooke's Law. Hooke's Law. Alright, so for Hooke's Law, we have the formula F is equals to K times X. F is force, K is the spring's constant, and X is the elongation. So dito sa Hooke's Law, it tackles how much force is needed to stretch or compress a spring in a certain length. For example, gaano ba kailangang kalaking force ang kailangang i-exert para ma-stretch yung isang spring. So, yun yung ating Hooke's Law. And remember that in Hooke's Law, pag yung force, ang naging sign natin is negative, it means that the spring is compressed. But if the force is positive, it means that the spring is stretched. Again, pag negative sign yung force, it means that the spring is compressed. But if the force is in positive, it means the spring is stretched. Ito kasi yung compressed and ito yung stretch. So, this negative and positive sign sa Hooke's Law, hindi ito direction, pero it tells us if the spring is compressed or stretched. So let's move on with this example. Calculate the force needed to stretch a spring given the spring's constant 120 Newton per meter and elongation of 30 meters. So the givens are our spring constant, ang symbol natin is K, 120 newtons per meter, and our symbol for elongation or length niya is X, and it is 30 meters. It means that if our elongation is in centimeters or kilometers, we need to convert this first into meters. Kasi meron tayong constant na unit na Newton per meter. So, for us to find the needed force, we only need to multiply the spring constant na 100 newtons per meter and the elongation, which is 30 meters. So if we encode this in our calculator, we will get the answer of 3,600 newtons. It means that, nakakancel out, our remaining unit is Newton. It means that we need to exert 3,600 newtons of force for us to stretch this spring. At para ma-stretch natin siya in 30 meters. Alright? It means that the amount of force is directly proportional to the elongation and to the spring's constant. Okay? Second example. Okay, number 2, determine the elongation of the spring if a force constant K is 48 newtons per meter with a 0.25 kilogram mass suspended from it. So let us all write the given. Given our spring's constant is 48 Newton per meter, our mass is 0.25 kilograms. So our unknown is the X or the elongation. So sabi dito, for example, this is our spring and this is the 0.25 kilogram mass. Ang tinatanong sa atin, what is the elongation of the spring? Okay? So from the formula of Hooke's law, which is F is equals to K times X, for us or using the triangle method, we have here F Kx. Since you are looking for x, it means that our formula is F divided by the the spring's constant, Since we do not have the value of force, but we have the value of mass, you all know na that for us to convert this to force or to weight, we will going to multiply the mass to the gravitational field strength or the acceleration due to gravity. Na-discuss ko na din yung gravitational field strength dun sa concepts, okay? So, 0.25 kilograms times 9.8 meters per second square. So, our force na is 0.25 times 9.8 is 2.45 newtons. So, we already have the value of F. So, substitute natin 2.45 newtons divided by the elongation or springs constant 48 newtons per meter. So, cancel natin yung force. So, 2.45 divided by 48 newtons per meter, our answer is 0.05 meters. It means that the spring with a mass of 0.25 will stretch at 0.05 meters. Okay, so ganun lang. Pag naman springs constant ang hinahanap, ang ating formula lang is F divided by X. Okay, so next example. So determine the mass of a fish that stretches a spring which is used as a scale for weighing fish to 7.5 centimeters with constant equal to 600 newtons per meter. So our given is the elongation kasi yung spring daw ay na-stretch to 7.5 centimeters and the constant is equals to 600 newtons per meter. Ang tinatanong sa atin is yung mass ng fish. So, gaano daw kabigat yung isda na nakastretch or nakapagpa-stretch dun sa spring into 7.5 centimeters, considering that the spring's constant is 600 newtons per meter. So, first, since ang tinatanong sa atin ay mass, kunin muna natin yung force. So we have here, F is equals to Kx. Wala naman tayong ibang pagkukunan ng mass, pero yung force lang. So 600 newtons per meter times the elongation. But before we proceed writing this elongation, since tayo ay naka-centimeters, convert this first to meters. So 7.5 centimeter times in 1 meter, we have 100 centimeters. So our answer is 0.075 or 0.08. But let's use 0.075 para mas accurate. Again, kinonvert lang tong amount of elongation into meters. So 7.5 centimeters is equals to 0.75 meters. And our force, equivalent force, 600 times 0.075 is 45 newtons. So this is the weight or the force of the fish. But we are going to look for mass or we are going to solve for mass. So, since ang force ay nakukuha pag multiply natin ang mass and the gravitational field strength or the acceleration due to gravity, for us to get mass, ano ang ating magiging formula? So, from the triangle method, F, mg, we are looking for mass. So, F divided by g. So, yung nakuha nating force, 45 newtons divided by 9.8 meters per second square. So, 45 divided by 9.8 is 4.59 kilograms. Kasi diba ang Newton natin, ang equivalent ay kilogram meter per second square. So, cancel out. Ang remaining unit is kilogram. So, this is our final answer. Kung masyadong nabibilisan, you may just replay the video. So simple lang naman yung ating process. So for our next topic, we have here the pendulum. Again, the concepts are already discussed. So sana napanood nyo na yung concepts before you watch this problem solving. So first, calculate the period of a pendulum if its length is 1 meter, 4 meters, and 9 meters. So our formula for period of pendulum is T is equals to 2 pi times the square root of the length divided by the acceleration due to gravity. Kasi di ba, kung matatandaan natin, yung pendulum, ayun yung bob na nakasabit using a spring. So, kaya siya napapanatiling nakababa is because of the action of gravity. Kaya kailangan natin sa formula yung ating value ng acceleration due to gravity. So now, let us solve for each period of pendulum pag iba-iba yung length. So, simple lang naman, 2 times 3.14 times the square root of length natin is 1 meters divided by 9.8 meters per second square. So 2 times 3.14 is 6.28. But you can encode this in your calculator ng isahan. Pwede naman. Medyo magkakaroon lang ng konting difference sa ating answer kasi nag-step by step ako. So 1 divided by 9.8 is 0.10. May kadugsong pa yan. Then cancel yung meter, so second square. So 6.28 times the square root of 0.10 second square is 0.32 seconds. So makakancel na So 6.28 times 0.32 seconds, so we have 2 seconds. It means that if the length of the pendulum is 1 meters, its period is 2 seconds. Alright? So now, let's move on with letter B. I will just change this. Same lang yung formula. Baguhin lang natin yung mga product. So, ang length na niya is 4 meters. So, lagay natin dito. 4 divided by 9.8 is 0.41 seconds square. Kasi yung meters pa lang ang nakakancel. And the square root of 0.41 seconds square is 0.64 seconds. So, itong 6.28, product to ng 2 times 3.14. So, 6.28 times 0.64 seconds is 4.02 seconds. So, if the length of the pendulum is 4 meters, its period is 4.02 seconds. Alright? So, it's up to you kung wala namang ibang diyang hahanapin. Given naman na yung length. So, if ito ang hahanapin, you must derive a formula. So, next, just erase this. Letter C, paano naman pag 9 meters yung length? So, lagay natin dito. Ganun pa din, 2 times 3.14 times the square root of the length, which is 9 na. 9 meters divided by 9.8. So, 2 times 3.14 is 6.28. 9 divided by 9.8 meters per second square. So, cancel the meters. Our quotient is 0.92 square seconds. So, the square root of 0.92 square seconds ay 0.96 seconds. So, 6.28 times 0.96 is 6.03 seconds. So, if the length of the pendulum is 9 meters, its period is 6.03 seconds. Okay? So, for our next topic, before tayong mag-waves, para iisa lang yung flow natin, sasama-samahin ko na mamaya yung about waves, yung na-involve yung ating parts ng wave. So, speed of sound in air. So, this problem was included na or showed to you during the past recorded discussion. So, calculate the speed of sound using the following temperature conditions. So, 20 degrees Celsius at ano daw naman ang speed of sounds if the temperature is negative 20 degrees Celsius. So, for our formula, let us first write or solve for the 20 degrees Celsius. So, we have the speed of sound is equals to 332. Ito yung speed ng sound at 0 degrees Celsius and if the atmospheric pressure is constant, or normal. This was discussed in the concepts na discussion, plus 0.6. 0.6, ito yung dinadagdag sa speed of sound kada taas ng 1 temperature or 1 degree Celsius, Again, 0.6 meters per second yung dumadagdag sa speed of sound if the temperature increases by 1 degree Celsius. So, 1 degree Celsius, 0.6 meters per second yung tinataas. Times the temperature, and ito nga yung ating unit. Hindi na dito sinama, dito na lang. Pero pwede din namang dito, 332 meters per second, 0.6 meters per second. Then mawawala na dito sa dulo pag dito niyo siya sinulat. So, substitute 332 plus 0.6 times 20 degrees Celsius and our unit. Since magkakaparehas, kaya dito lang sa dulo. Pero wala naman yung kaso, kung dito niyo ilagay. So, again, ito lang naman yung ating isa-substitute. So, 332 plus 0.6 times 20 degrees Celsius is 12, kahit hindi na natin ilagay yung degrees Celsius, meters per second. So, the speed of sound, if the temperature is 20 degrees Celsius, is 344 meters per second. So, let us move on with letter B. Paano naman pag negative 20 degrees Celsius? So, same formula. 332 plus 0.6 times the temperature, meters per second. So, 332 plus 0.6 times negative 20, kahit wala na din ditong unit, meters per second. So, 332 plus 0.6 times negative 20 is negative 12 meters per second. So, magiging subtraction na yan kasi magkaibang sign plus and negative. So, 332 minus 12 or 332 plus negative 12 is 320 meters per second. So, ganyan lang kadali. Don't forget lang the formula. So, di ba mas malamig pag negative 20 degrees Celsius? Negative 20 degrees Celsius is colder than 20 degrees Celsius. That's why, pag mas malamig or if the temperature is lower, the speed of sound becomes slower. Or if the temperature decreases, the speed of sound also decreases. Since ito yung mas mataas na temperature, if the temperature increases, the speed of sound also increases. Di ba mas mabilis naman itong 344 kesa sa 320? 344 meters per second is faster than 320 meters per second. Di ba? So, ito din yung nagiging dahilan or reason or scientific explanation kung bakit pag malamig ang panahon, parang nagiging peaceful yung paligid. Or, not necessarily peaceful, pero parang nalilesen yung noise. I do not know if ako lang yung nakaka-feel, pero maybe some of you ay ganun din na pag mas malamig yung panahon, parang ang tahimik, may mga konting noise pero hindi ganun kaingay, hindi katulad pag sobrang init ng panahon. Kasi nga pag malamig, mabagal mag-travel ang sound. Then pag mainit, mabilis mag-travel yung sound. Since meron tayong sinusunod na 'di ba, itong 332 meters per second, ito yung speed of sound if the temperature is at 0 degrees Celsius and if the atmospheric pressure is normal or constant. It means that if the givens, I'll just erase some of this. If the givens are in Fahrenheit or Kelvin, we will convert that first into degrees Celsius. So I will no longer give an example of this kasi it is easy naman, no? So sample na lang ng pagko-convert. If the given is in degree Fahrenheit, convert this first into degrees Celsius. So how can we convert this? Degree Celsius is equals to 5/9 times the degree Fahrenheit minus 32. Yung minsan itong 5/9 ay nandito sa dulo. So 5/9 times 68 minus 32. So if you encode this to your calculator, ang answer dyan is 20 degrees Celsius. So 68 degree Fahrenheit is equals to 20 degrees Celsius. Tsaka natin to gagamitin dito sa ating formula. So ito lang yung formula pag magko-convert tayo ng Fahrenheit to Celsius. Pag naman Kelvin to Celsius, di ba ito yung ating as a unit for temperature, Kelvin? So, for example, we have 326 Kelvin. So, for us to get the equivalent in degrees Celsius, we will just subtract 273.15. So, 326 Kelvin minus 273.15. Ito lagi ang gagamitin, pag mag-subtract para makuha yung Celsius. So, 326 minus 273.15 is 52.85 degree Celsius. So, this is what we are going to use if we will compute for the speed of sound. This degree Celsius, not the Kelvin, not the Fahrenheit. Okay, so that is the process of converting and calculating the speed of sound in air. So next topic natin is about Mach number, and this has something, or this is in connection with it, but then with the speed of sound. But now we have an object which is an aircraft, kasi diba itong Mach number nga is used to determine the speed of an object na mas mabilis pa sa speed of sound. So we have here calculate the Mach number of an aircraft traveling at sea level with a temperature of 0 degrees Celsius using the following speeds: 1,800 kilometers per hour and 900 kilometers per hour. So let us solve first for this one. And we know that Mach number is equals to the speed of an object or aircraft divided by the speed of sound. Since ito ay nasa sea level, we will assume that the atmospheric pressure is normal. Kasi iba na pag sobrang taas na naiiba yung ating speed of sound. And since dito sa physics 1 naman, we will consider lang pag nasa sea level. Yun lang naman yung need ninyo. So, speed of the object is 1,800 kilometers per hour. And yung speed of sound, we all know that the speed of sound at 0 degrees Celsius at a constant pressure is 332 meters per second. Again, this was mentioned in the separate from the separate recorded discussion. So, before we divide this 332 meters per second, since this is an aircraft and this is so fast, we will just convert this into kilometers per hour. Kasi malaki na yung object, mabilis na, hindi na tugma yung meters per second. So, convert this first into kilometers per hour. So, kailangan nasa ilalim yung meters. Baguhin ko lang. Gawin kong ganito para mas makasunod, meters per second. Kailangan yung meters ay nasa ilalim para makancel. Ang kailangan nating unit is kilometers. So, 1 kilometers is equals to 1,000 meters. Times, yung seconds naman, kailangan nasa taas. At ang kailangan nating unit is hour. So, in 60 seconds or in 1 hour, we have 60 minutes. In 1 minute, you have 60 seconds. So, 60 times 60 is 3,600 seconds meron sa 1 hour. So, 332 times 3,600 divided by 1,000 is 1,195.2 kilometers per hour. So, ito yung gagamitin natin pan-divide. So, again, Ma'am Santo nakuha. This is the speed of sound in kilometers per hour. So, 1,800 divided by 1,195. So, cancel natin yung units kasi magkapareha sila and nag-divide tayo. So, our answer is 1.5. Ang unit natin ay Mach. So, this is the Mach number of the aircraft if its speed is 1,800. And di ba meron tayong mga conditions doon? Since our Mach number is more than 1, sinasabi natin na this is in supersonic condition. Kasi more than 1. So, next, letter B. Just erase this one. Letter B, ang hinahanap natin naman or our speed is 900 kilometers per hour. So, madali lang. Kasi kalahati siya ng 1/8. So, kalahati din ng 1.5. But let us perform this. So, Mach number is equals to speed of the object divided by speed of sound. So, 900 kilometers per hour divided by, ito pa din, 1,195.2 kilometers per hour. Cancel natin. 900 divided by 1,195.2 is 0.75 Mach. And since this is in less than 1, sinasabi natin na pag less than 1, yung aircraft ay in subsonic condition. So, hindi naman tinatanong kahit hindi nyo naman i-identify. I only gave an example. So, ayun, kalahati ng 1.5, 0.75. Kasi yung speed dito sa letter B ay kalahati din sa letter A. So, our Mach number for B is 0.75 Mach. So, second example, a military interceptor airplane flies at Mach 2. So, given ang Mach number, determine its speed in kilometers per hour. So, let us first write all the given. Our Mach number is 2 Mach and lagay ko lang dito yung ating speed of sound in kilometers per hour kasi yun yung hinahanap. Pero kung meters per second ang nakalagay, pwede natin gamitin yung 332 meters per second. But since in kilometers per hour, we will use its equivalent in kilometers per hour. So from our formula, paiksiin ko na lang para kasya, Mach number is equals to speed of the object divided by speed of the sound. We are going to find the speed of the object. So, we will have to use the formula Mach number times the speed of sound. So we have 2 Mach times 1,195.2 kilometers per hour. So 2 times 1,195.2 kilometers per hour, we will get the speed of the object with the equivalent of 2,390.4 kilometers per hour. So therefore, yung interceptor airplane na merong 2 Mach, ang speed niya ay 2,390.4 kilometers per hour. Expecting or assuming that it is at sea level and the temperature is at 0 degrees Celsius. Okay? So, pag hindi naman 0 degrees Celsius yung temperature at kukunin natin yung Mach number, kukunin muna natin yung speed of sound using the formula earlier na 332 plus 0.6 t meters per second. Ito gagamitin natin if the temperature here is not 0. So, kung ano yung makuha nating temperature dito, kung ano yung makuha nating speed dito, yun yung gagamitin natin dito sa speed of sound. But since 0 ang ating given na temperature, we will assume that the speed of sound is 1,195.2. This is the constant speed of sound if the atmospheric pressure is constant or normal and if the temperature is at 0 degrees Celsius. But again, if the temperature is not 0 degrees Celsius, we will get first the speed of sound using the given temperature, and the speed of sound that you will be using that here. And yun yung isa-substitute nyo dito sa speed of sound. Okay, so these are the examples lang for Mach number. Okay, next topic, we have here the wave. And the wave equation is given as the speed of the wave is equals to frequency times the wavelength. Again, this sign or symbol is lambda, or in physics, this is read as the wavelength. Okay? So, again, ang wavelength natin ay yung distance from two crests or two throws. So, ayun, na-discuss naman na yan dun sa concepts. Okay. So, I will no longer write the problem kasi andun ito sa recorded discussion. So, number 1, determine the wavelength of the sound wave if the sound from trumpet travels at a speed of 350 meters per second in air and if the frequency of the note played is 300 hertz. Again, determine the wavelength. Gaano daw kalayo yung dalawang crest or throws if the speed of sound is 350 meters per second and if the frequency is 300 hertz. So from our given and from this wave equation, we are going to solve for the wavelength. And our formula from here, you can use the triangle method. So we have speed of sound divided by the frequency. So substitute natin 350 meters per second divided by 300 hertz. Our answer is 1.17. Since we are talking about wavelength, yung layo, our unit will be meters. Kasi di ba, ma'am, paano yung hertz? Paano yung second? Di ba ang hertz ay meron siyang kinalaman sa second? Ito'y para sa frequency. So, pwedeng na-cancel na tong hertz and second. But we cannot cancel that kasi nakikita niyo namang magkaiba. But since again nga, we are looking for the wavelength. Ayan. So, we have the unit of meters. Okay? Number 2, again, this problem ay nandun sa isang recorded discussion. If a 260 Hz sound from tuning fork has a wavelength of 1.3 meters, at what speed does the sound travel? Ano daw naman yung speed ng sound if the tuning fork has a frequency of 260 Hz and its wavelength is 1.3 meters? So, since speed of sound or speed ng ating waves speed ng waves ang hinahanap, we have this formula, frequency times the wavelength. So, we have 260 Hz times 1.3 meters. Our speed of the wave, 260 times 1.3 is 338 meters per second. So, tandaan yung mga unit ha, since meron tayong unit dito na hindi pwedeng i-cancel. Pag wavelength, meters. Pag speed of sound, meters per second. Okay? So, ayan, nandito yung ating mga final answer. Don't worry kasi sa wave equation ay ito lang naman yung kailangan yung tandaan. So, mas madali, 'di ba, pag tatlong quantities lang, speed, frequency, and wavelength. Pwedeng gamitin yung triangle method. So, third example doon sa ating PowerPoint ay determine the frequency of a sound wave if its wavelength is 10 meters and travels with a velocity or speed of 350 meters per second. So, ano daw naman yung frequency ng sound wave if its wavelength is 10 meters and it is traveling at 350 meters per second square? So, from our triangle method, or from our triangle, ayan, since ito yung hinanap natin kanina, so V divided by F. Ngayon naman, frequency ang hinahanap, so we have V divided by lambda, or speed of sound divided by the wavelength. So, speed of sound is 350 meters per second divided by its wavelength na 10 meters. So, cancel natin yung meters. 350 divided by 10 is 35. Since frequency, pag seconds, di ba, ay para yan sa period or sa time. Since frequency, our unit is hertz. So, remember that ha. Speed of sound, meters per second. Wavelength, 1.17 meters. Frequency not 1.17. Wavelength is meters. Frequency I hertz. So, remember these units. Okay? So, meron pa akong additional na dalawang example sa waves. So, isusulat ko yung problem. These are the two additional examples. So, for determine the speed of a water wave in a pond that has a wavelength of 0.08 meters and a frequency of 2.5 Hz. So, our given are wavelength 0.08 meters, frequency 2.5 Hz. So, sorry for my handwriting na So, since you are going to look for the speed, so V is equals to frequency times wavelength. So, frequency is 2.5 Hz times the wavelength of 0.08 meters. So, if we multiply this 2.5 and 0.08, we will get the answer of 0.2 since you are talking with speed. So, meters per second. So, this is our answer. So, number 5, last na to. Sa wave lang, sa wave. Calculate the frequency of the wave if the wavelength in the water wave is 4 meters while the crest travels since 9 meters. Meron na tayong wavelength na 4 meters. So, ibig sabihin, hindi na to wavelength. Meters yan, di ba? Yes, pero meron na nga tayong wavelength, hindi pa pwedeng dalawang wavelength. So, since this is in meters, you can assume that this is the distance na na-travel nung crest. So, we have the distance of 9 meters and the crest travels that 9 meters in a matter of 4.5 seconds or the time. It means naka-cover ng 9 meters yung wave sa loob ng 4.5 seconds. We are going to look for frequency. And our formula nga to get the frequency is speed divided by the wavelength. We have the value of the wavelength, but we do not have the value of speed. E di ma'am, F times lambda or F times wavelength, hindi pa pwede kasi wala pa nga tayong frequency. So, paano ba natin makukuha yung speed using this formula? So, from our linear motion, we can calculate the speed by dividing the distance by time. Speed is equals to distance divided by time. So, since meron tayong distance at time, pwede natin tong gamitin. So, distance is 9 meters divided by 4.5 seconds. So, 9 divided by 4.5 is 2 meters per second. So, we already have the speed. Okay na. So, we can now solve for frequency. So, frequency is equals to the speed 2 meters per second divided by the wavelength, which is 4 meters. So, 2 divided by 4 is 0.5. And again, yes, makakancel pero hindi. We are not going to use or we will not going to use the second, but instead, we will use the unit of hertz because we are talking about frequency. So it means that the frequency of the water wave is 0.5 hertz. So again, if it is too fast for you, you may just replay. So now, we are going to tackle naman about beats. So, yeah, the concepts was discussed already. So, let us have the problems that are included in the PowerPoint presentation there. So, when note is played on the piano, a tuning fork with a frequency of 256 Hz is produced simultaneously. There were 9 beats heard. There were 9 beats heard in 3 seconds. What is the frequency of the piano note? So again, what is the frequency of the piano note? Okay. So for us to get the beat frequency, katulad lang nung kanina sa waves, imbis na cycles, so we have beats divided by time. So we have 9 beats divided by 3 seconds. So our beat frequency is 3 Hertz. So 3 beats per second or 3 Hertz. Remember that basta frequency, ang unit ay Hertz. Parang di ba pag force, Newton, pag energy, Joule, pag frequency, so Hertz. So we are going to solve for the frequency of the piano note. So, dun sa ating recorded discussion, I presented to you the formula of beats na F sub 2 minus F sub 1 or the first frequency minus the second frequency or pwede din namang second frequency minus the first frequency. Anything will do kasi possible na dalawa yung sagot natin dito. So, let us use this formula. So, beat frequency is equals to 3 Hertz. Ito yon. Then, our first frequency is 2, lagyan natin f sub 1, yan. 256 Hertz minus, ito yung ating hinahanap, f sub 2. So, we all know na para ma-transpose, or para ma-isolate yung f sub 2, since meron tayo ditong operation na subtraction, we can transpose this 256 dun sa kabila. So, 256 minus 3 Hertz, this is also Hertz, is 253 Hertz. So, this is the beat of the piano note, or pwede din namang 259. Pag ginawa natin tong isang formula, so we have 3 Hertz is equals to f sub 2 minus 256 Hertz. So, ito parang parenthesis, itong line na yan. So, transpose sa kabila, since ito ay negative or minus, magiging positive doon. So, 256 plus 3 Hertz is 259 Hertz. So, kahit alin dyan yung maging answer nyo. Okay? Okay, so let's continue. Ito ay connected pa din dun sa beats or the frequency natin. So, again, the problem ay nandun sa isang recorded discussion, hindi ko na isusulat. So, the C string of a violin is 33 centimeters long. Pag sinabi nating long, so length, It is 33 centimeters long. And it's, yung string na C string na meron 33 centimeters long, yung natural frequency ng C string is 130 Hertz. Where must the violinist place his finger on the string to produce a frequency of 280 Hertz? Or itong 288 Hertz natin, this is the frequency of the D string ng violin. Or violin, no? So, saan daw kailangang i-place ng violinist yung finger niya para makaproduce ng D sa violin, or yung note na D, and the D note has the frequency of 288 Hertz. Since the involved is frequency and length, I gave you there, or from the separate discussion, I gave you the dependence of frequency of vibrating string dun sa iba't ibang factors. Since we have F and L, possible, or we can use the first factors, which is frequency is inversely proportional with length. Sabi dyan, frequency is inversely proportional with length. So, pabaligtad. Yung isa tumaas, yung isa bababa. And since it is inversely proportional with length, nandito yung ating L sub 2, nandito yung ating L sub 1. Frequency is inversely proportional with length. May length din dito, pero yun ay sa first. First. So, nasa magkabaligtad na part, so inversely proportional. So, ganyan mag-write ng formula, pag dun sa mga factors na yun. So, let us substitute. Ito yung ating unknown. But if you are not confident nga to derive formula, you can substitute the given. Then sa solution na lang tayo kumuha ng final answer. Kahit hindi na mag-derive ng formula. So, our second frequency, which is yung sa D, is 288 Hertz divided by the frequency of the C string, which is 130 Hertz, is equals to the length of the C string, 33 centimeters, Since ang violin ay maiksi lang, kahit hindi na i-convert sa meters, then ito yung ating hinahanap. So what are we going to do for us to find our length kung saan natin dapat ilagay yung string, yung finger? So, ayan, na-substitute natin and we can now visualize ano yung pwede natin gawin. So, pwedeng pag magde-derive tayo ng formula, erase muna natin to. Turuan ko na kayo, no? Cross multiply lang. Ito yung ating hinahanap. So, F2 times L2. So, we have F2 L2 is equals to F1 times L1 is F2 L1. F1 L1. Since we are going to solve lang for L2, divide both sides by F2 para ma-cancel out natin. So, to isolate L sub 2, divide both sides by F2 for us to cancel out. So, our formula is L sub 2 is equals to F sub 1 times L sub 1 divided by F sub 2. So, let us substitute F sub 1, 130 Hz, times L sub 1, 33 centimeters, divided by 288 Hz. So, dito pa lang kita na natin, magdi-divide tayo, cancel out na natin yung Hz. So, if we are going to encode this to our calculator, 130 times 33 divided by 0.08, just like this, our answer is 14.89, or since 895 yan, so pwedeng 14.90 centimeters. So ayan. Our answer is 14.90 centimeters. So, ganun lang magsulat ng formula from the factors. So, meron pa tayong second example doon. So, yun naman about sa piano. So, let me just erase this. Okay, so from the problem, a piano string with a pitch of A, yung pitch daw nung A na note is 440 Hz. Is under a tension or pinipindot daw. Pag pinipindot natin, nagre-release tayo ng tension or ng force. So, we have the F1 of 140 Newton. So, yung ating piano string na A daw, which has 440 Hz, pinipindot down ng 140 Newtons or is under a tension of 140 Newtons. What tension would be required to produce a high C? Yung C note naman natin ay merong frequency na 523 Hz. So, I will read the problem again. A piano string with a pitch of A that has 440 Hz is under a tension of 140 Newtons. What is the tension, or what tension would be required to produce a high C that has a frequency of 523 Hz? Since the involved quantities are frequency and force or the tension, we can use the second factor. But instead of force, let us use the letter T. Since tension naman yung nasa problem, but pwede ding maging F kasi nga Newton. But since ang nasa problem and nasa factor ay yung term na tension, so we use a letter T. And according to the second factor, sana may copy na kayo nun nandun yun sa last recorded discussion about wave. Since the second factor states that the frequency, laging nasa taas ang 2. Dito. The frequency is directly proportional to the square root of tension. Kanina, di ba? I will just compare lang. Kanina, frequency is inversely proportional with length. Kaya itong parehas na to ay nasa magka-opposite side kasi inversely proportional. Dito, since sinasabi, the frequency is directly proportional to the square root of tension, therefore, ang t sub 2 natin ay nandito sa numerator din. So, pag directly proportional, magkatapat sila. F sub 1, T sub 1. F sub 2, T sub 2. Okay? So, since we are going to look for T sub 2, we are going to look for T sub 2, what are we going to do? So, we can just cross multiply T sub 2, then F sub 1 is equals to T sub 1 times F sub 2. Okay? So, for us to isolate this one, for us to isolate this T sub 2, divide both sides by F sub 1. So, cancel out. So, our formula is so since both sides tayo ay may square root, so we will have the formula T sub 2 is equals to, malilipat ito dito sa last part, and para nga ma-cancel out yung ating square root, we will square F sub 2 divided by F sub 1 square times T1. Okay, so let us substitute. So F sub 2 is 523 Hertz divided by F sub 1, 440 Hertz square times 140 newtons. So, para sure, na tama yung makukuhang answer ito, square nyo muna yung 523 and square nyo din yung 440 Hertz. So, baka kasi malito. So, pali magiging wait lang, where's the, okay. So, F sub 2 square, then F sub 1 square times T1. So, if you got the answer na, parang ganito yung mangyayari. Ayan. So, our tension 2 or the tension should be 198 newtons or 197.80 newtons. Okay? So, pag naman yung factor na gagamitin nyo is yung third factor, which is frequency is inversely proportional with the diameter. Since inversely proportional, yung D sub 2 natin ay nandito sa ilalim and D sub 1 is nasa numerator because it is inversely proportional. And if you are going to use the fourth factor, which is the frequency is inversely proportional as the square root of the density. So, inversely proportional ulit. So, ang ating square root of density 2 ay nasa ilalim at yung density 1 ay nasa itaas. So, this is the symbol naman for density. Ito yung nandun naman sa recorded discussion ng fluid mechanics. Okay, so ganyan lang. Pag inversely proportional, nasa magkabilang side yung may parehas na subscript. Pag directly proportional, yung may parehas na subscript ay parehas nasa numerator or nasa denominator. Okay? Okay, so this is our last topic for this recorded discussion, the Doppler effect. So again, the problem is already stated sa inyong previous recorded discussion about waves. So again, the Doppler effect can be expressed as the frequency 2 is equals to the first frequency times the speed of the sound in the medium divided by, again, the speed of the sound in the medium plus or minus the speed of sound or the speed of the source through the medium. So again, take note that mag-a-add tayo or we are going to use addition if the source is moving away from the observer, and minus or negative if the source is moving towards the observer. So based from our sample problem, I will just read that. As it approaches a hiker standing on the highway, a car traveling at 100 kilometers per hour blows its horn, so bumusina. Determine the frequency of the sound waves reaching the hikers if the car has a frequency of 440 Hz and the temperature of the air is 0 degrees Celsius as the car approaches. So, dalawa yung ating hinahanap. So, for example, ito yung hiker. As the car approaches the observer and as the car or after it passes the observer. So remember that the speed of sound is constant if the temperature is 0 degrees Celsius, and based from the problem, the temperature is 0 degrees Celsius. And we will assume that the atmospheric pressure is normal and constant. So letter A. For us to solve letter A, we have the formula f sub 2 is equals to f sub 1 times v. So add or subtract. Since the source is moving towards the observer, we are going to use minus speed ng ating car. Okay. So, dito ko na lang isusulat our frequency. Ito ay yung speed ng ating car or nung source. V sub S, S for source. So, we have 440 Hz times, ano nga ulit yung V? So, ang ating constant speed of sound if the temperature is 0 degrees Celsius and the atmospheric pressure is constant and normal is 332 meters per second. Divided by, V ulit, 332 meters per second minus, since ito ay naka-kilometers per hour, pwede nyo namang gamitin itong kilometer per hour. Pero ganito na lang, since car lang naman, we can express that as meters per second. So let us convert 100 kilometers per hour, km per hour, to meters per second. So in 1 km, we have 1,000 meters. And in 1 hour, we have 3,600 seconds. So let us encode 100 times 1,000 is 100,000 divided by 3,600. Our answer is 27.78 meters per second. So 100 kilometers per hour is equals to 27.78 meters per second. Okay, so 440 hertz times 332 meters per second. Again, this is the speed of sound divided by 332 meters per second minus, bakit minus? Kasi the source is moving towards or papalapit sa observer. Pag papalapit, minus. Ano? So, let us encode this in our calculator. 440 hertz times 332 divided by 332 minus 27.78. Okay, meters per second. So, our answer, cancel na natin to. Our answer is 480.18 hertz. This is the frequency when the source is moving towards the observer. So, sabi naman, same formula. F sub 2 is equals to F sub 1 times V. And since lumagpas na yung car dun sa observer, so lumagpas na, ibig sabihin papalayo na, so plus speed of the source. So same lang ulit, 440 Hz, ito yung frequency ng busina, times 332 meters per second, box natin tong answer natin, divided by 332 meters per second plus 27.78 meters per second. So, hindi nagbago yung bilis niya, no? Kaya ito pa din. So, let us just change the operation. Instead of subtraction, since papalapit nga, so we will make it as addition. So, our answer is 406.03 meters per second. So, these are the answers. So, nung lumagpas na yung car dun sa observer or sa hiker. So, it means that, wait lang, for you to better understand, I will draw a simple, very simple diagram. So, for example, this is the observer. If the car is approaching the observer, makikita natin na mas mataas yung frequency, or the frequency here is higher than the frequency when the car is moving away. It means that the sound waves are close to each other. Kaya nga mataas yung frequency. Sabi ko nga dun sa recorded discussion, as the frequency increases, the wavelength decreases. Mas umiiksi yung wavelength. And when the car passed the hiker or the observer, or when the car is moving away the observer, the frequency of the sound waves decreases. That's why it is only 406.03. And as the frequency decreases, the wavelength increases. That's why habang lumalapit, mas lumalakas kasi papadami yung sound waves. And habang lumalagpas or lumalayo, mas humihina kasi paunti na ng paunti yung frequency na sound waves. And that is the Doppler effect. Alright, so we will be having a separate recording na lang ulit tungkol sa fluid dynamics, yung problem solving na lang doon. So, I hope you learned something. So, thank you very much.